Hello, 6th grade. Our next video is going to be corresponding to lessons 11.2 and 11.3, and they are about solving one-step equations using the inverse operation. And we're going to be dealing with equations that involve adding and subtracting and multiplying and dividing. But the concept of using the inverse operation is the same in both lessons. So this video will cater to both 11.2 and 11.3. All right, so let's just focus and zoom in on adding and subtracting equations. Okay, so I'm thinking of a number. When I add the number I'm thinking of to 10, I get 35. What is the number I am thinking of? Well, I think a lot of you found out in 6 seconds. Not even a split second, you were able to do it. But let's take a minute to think about the equation we could write. So if I'm thinking of a number and I don't tell you, what could we use to represent an unknown number? You got it, a variable. So I'll just use n for number that I'm thinking of. I say when I add 10 to it, I get 35. So I'll add 10 to this number. It's going to equal 35. So what is the number I'm thinking of? Well, what plus 10 is 35? Right, 25 plus 10 equals 35. But my question to you is, how did you get that 25? Did you just know it? Did it just pop out into your head? Or did you use something to help you figure out that the number I'm thinking of is 25? A lot of you in class say that you would then take 35 and subtract 10. So 35 minus 10 would give you 25, and that's exactly what these lessons are all about. It's using the opposite operation, or a better word would be to use the inverse operation. So the opposite of addition is subtraction. So if I'm thinking of a number and add 10 and I get 35, I can start at 35 and take away 10 and get 25. And that's called using the inverse operation. So this slide you can come back to it, you can copy it, you can print it out, but these are the rules for solving one-step equations. So you can refer back to these throughout the video and throughout lessons in class. And these are actually probably in your notes anyway, because this was a slide from your classwork. So let's look at the first rule. You use the opposite operation, or we better call it inverse operation, of the one that is shown in the equation. So if the equation has subtraction, you use addition. If the equation has multiplication, you would use division. We're trying to isolate the variable. That means get the variable alone. We're trying to have the variable equal something. Okay, so step 3 is add or subtract, multiply or divide on both sides of the equation, which we call balancing. And then the fourth rule is to always check your work. And we know that, but you can check your work by substituting the value that you got by using the inverse operation. Some of you might have used a flow chart to help you solve for the variable. And I'm going to give you an example of that. Sometimes we use modeling, we use our algebra tiles, or our cups and our chips. There's lots of ways to figure out what the variable is. It's just a matter of using a system that works for you. Okay, so I'm thinking of a number G. I'm going to add 15 to it, and I'm going to get 45. So I'm thinking of this number G, I'm going to represent it as G. So there's G in the circle. If I add 15 to G, I'm going to get 45. And something that you have done in class is you would say, well, if you're thinking of a number and you're adding 15 and you get 45, well, 45 minus 15 will get us to G. And using our flow chart, we could say 45 minus 15. This is showing the inverse, the opposite. What is 45 minus 15? Well, that's 30. So therefore, G has to be 30. But the way that we check it is we plug in 30 for G. So is 30 plus 15 45? Well, 30 plus 15 is 45. Is 45 equal to 45? Check. They're balanced. Think of it as a balance scale. 30 plus 15 apples are on one side and 45 apples are on the other. And they would be equivalent. Okay? So showing using the inverse operation, not using a flowchart, is we can just take 15 from each side. So in class, your teachers might have said something like this. If we thought of this as a balance scale, like what you use in science class, and on this side of the balance scale is a number plus 15, and it has to balance out to be equivalent to 45, you could say, well, what plus 15 is 45? Well, 45 minus 15 is 30. So if I wanted to isolate G, if I wanted to get G alone, I would take these 15 away. But in what you do on one side, because if this is a balance scale and there's 15 apples on one side, if I take 15 off, I have to do the same thing to the other side. So 15 minus 15, I've canceled that out. It's a zero pair, and I'm just left with the G equaling, and if I take 15 from 45, I have 30. And that's another way to find out that G is equal to 30. And as the fourth step always says, you need to check. Rewrite your original equation. Plug in for the variable. G is 30 plus 15 equals 45. And we get 45 equals 45. Check. Okay, so our whole goal is to isolate the variable. The first method, using a flowchart, you can use for very basic equations. But as you move up into 7th grade and 8th grade and you're using more complex equations and trying to figure out what the variable is, you're going to want to use this inverse operations balancing method, doing something to one side and then repeating it on the other so that you can isolate that variable. All right, so here's a few more examples. I'm thinking of a number. When I add 7, I get 56.5. I'm going to use the inverse operations method of isolating the variable. And I notice that m plus 7 is on one side of the scale, and it equals 56.5. So if I want to isolate that variable, I want to know what m is. I want to have m equals something. I'm going to use the inverse operation. So if I see addition here, I'm clearly going to then use subtraction. So here's my variable, and I want to keep it there. I have the variable being added to 7. So if I take this 7 away, what I do to one side, I have to do the other. And then I would take 7 away from this side. These 7's cancel out. There's nothing left. I have my variable isolated. M is going to equal, and then I just have to do the math on this side. And then so 49.5 is m. You can use the flowchart or you can just work backwards. Some number plus 7 equals 56.5. Well, 56.5 minus 7 is m. Well, what I did in front of you here is just showing you how to show your work and how to show that you're balancing each side of the equation. Of course, then we have to check, is 49.5 plus 7 equal to 56.5? Well, yes, 49 plus 7 is 56, and the 0.5 is equal to 56.5. Check. So our work is correct. All right, so let's do the subtraction equation. T minus 22 equals 67. Well, what number minus 22 is 67? I could take 67, I could add it to 22, and that would give me T. The way I show my work is I want to isolate the variable, I want to get it by itself. So I need to take away that 22. But I can't just take it away. I can't just erase it. I have to do something in order to isolate t. So I could do 67 plus 22. I know I'm going to be adding 22 to get t, but in order to show my work, if I add 22 to negative 22, I'm left with a 0 pair. So t is equal to 89. 89 minus 22 should be 67. Let's check. 89 minus 22. Does that equal 67? Well, 89 minus 22 is 67, so 67 equals 67. Why don't you do the next two on your own? Press pause on the video, do them on your own, and then when you come back, you will be able to assess yourself. Alrighty, so you should be able to check your own work. When you look at the equation n plus 22.5 equals 78.98, you can say to yourself, okay, I'm thinking of a number. When I add 22.5 to it, I get 78.98. Therefore, the inverse of that would be 78.98 minus 22.5, and you should get 56.48. Then the second equation is r minus 56 equals 23. So the inverse of subtraction is addition. So 23 plus 56 should give us r, which is 79. And when you do your checks, you should know that your answer is correct. And that's the great thing about these checks, is that if it doesn't work out, that means you've done something wrong. So checking your work is really important. Okay, here's a real life situation that probably some of you have been in, actually. After Mary spent $5 of the money she earned selling lemonade, she had $15 left. If you let M equal the amount of money Mary earned selling lemonade, can you write a subtraction equation in order to find out the amount Mary earned selling the lemonade? Well, if she has a certain amount of money, M, and she goes and spends 5, so we're taking away 5 from the amount she earned, she's left with $15. So I'm thinking of a number. I'm going to take 5 from that number and I get 15. So you can think about that flow chart. We could have 15 plus 5. That will give us M. 15 plus 5 is 20. So we know M is going to equal 20. Well, how can we show it using the inverse operation? Well, let's rewrite the equation. M minus 5 equals 15. And again, think of this like a balance scale. I have a certain amount on one side of the balance scale, which is M minus 5, and the other is equal to 15. So the M minus 5 has to equal 15. Well, we want to isolate that variable. We want to get it by itself. So in order to do that, we need to do the inverse operation. So if I see subtraction, I know I'm going to use addition. I'm going to be adding that 5 to each side. These cancel out. M is equal to 20. And I can check my work, rewriting the expression, and plugging in for the variable. 20 minus 5 equals 15. 20 minus 5 is 15. Is 15 equal to 15? Yes, it is. Now we're going to zoom into 11.3, which is multiplying and dividing. It's the same strategies. We're just going to use the inverse operations in order to help isolate the variable. Alrighty, I'm thinking of a number. If I divide it evenly into 5 groups, there are 2 per group. So what number could I possibly be thinking of? Well, below you'll see I created a flow chart. I'm thinking of a number n. I take that number and I divide it by 5, and I get 2 per group. So what would be the inverse operation? What could I do? Or what could you say in your head you would do? Most of you in class said, oh, if I did 2 times 5, I'm going to get my answer. And that's true. What times 2? What times 5? 2 times 5 is equal to 10. So in my check, I could say, is 10 divided by 5 2? Well, 10 divided by 5 is 2. Is 2 equal to 2? Yep. So this is just an example of showing you how you can use the inverse operation. And it goes the same with division and multiplication. Here's another one. I'm thinking of a number. When I multiply the number by 5, I get 100. What is the number I'm thinking of? Well, I know all of you in a split second thought to say, well, if you do 100 divided by 5, you'll get m. And that's exactly correct. We're doing the opposite or inverse of the math that is going on here. So some number times 5 is 100. Well, 100 divided by 5 is going to give us m. And we all know 100 divided by 5 is 20. And in order to check our work, we could write it as some number 20 times 5 equals 100. 20 times 5 is 100. Is 100 equal to 100? Yes, it is. So that's correct. Why don't you press pause on the video and try to solve the following. Try to figure out what the variable is and try to use the inverse operations and balancing. So what you do to one side, you have to do to the other. And then when you're done, you can press play and the answers will be there. Alrighty, why don't you self-assess? What number times 5 is 100? Well, I know if I see multiplication, I can use division to help me solve for the variable. So I'm going to divide each side by 5, or the number that's being multiplied by the variable is also the number that's going to be divided. You're going to take the variable and divide it by that. And 5 divided by 5 is 1, so I'm just left with 1m. 10 divided by 5 is 20, so m equals 20. And my check shows that m has to be 20 in order for 5m to be equal to 100. The second equation is some number divided by 5 equals 2. Well, we all know in our head 10 divided by 5 is 2, but how do we show that we get 10? Well, if I took 2 and multiplied by 5, I'd get 10. But what I do to one side, I have to do the other. So n over 5, or some number divided by 5, then multiplied by 5, is really like saying you're just left with n, right? So n divided by 5, that's a division. N divided by 5 times 5, these two are just opposites and cancel each other out. So you're just left with n, but when we multiplied one side by 5, we have to multiply the other to keep it balanced, and 2 times 5 is 10. And obviously in my check, when I did the check, 10 divided by 5 equals 2, and 2 equals 2. I hope this video helps you review inverse operations and how useful they are in solving for the variable. More importantly, it's showing your work. It's really showing that what you do to one side, you do the other, and that you keep a balance in the equation in order to isolate that variable. And always remember to do your check. We'll really be looking to see if you're showing your check, because if you show your check, chances are you did the question correctly.